Hi everyone. This is strictly optional content to talk about paired differences. So you're not at all responsible for this. There might be one or two example problems that I've given on this or in the handout, but you're certainly not responsible for this. I just wanted to make a video to cover these extra slides. So here what I'm covering here is I'm talking about what it is we want to do to be able to make comparisons between populations, but we don't have independent samples. So if this happens, we can't use the large or small sample t-tests because those required independent and symmetric populations. So for example, suppose we want to compare the number incarcerated at 2 jails in Pittsburgh. So just to illustrate, we could randomly select days and then take a census count at each jail. However, once we chose the sample of days for jail 1, this is going to be the same sample of days for jail 2. But the number in each jail is probably going to be strongly correlated across days. So there's times when we expect more or less people in both jails. So suppose after the Pens lose Game 5 of the Stanley Cup Finals, or after they win Game 6, or during Steeler home games, or during whichever else. Essentially the issue in this example and many others is that we can get larger variation within the samples in comparison to small differences between sample means. So that's as the jail population rises and falls in both jails together because of external events, so we aren't able to use our standard t-test. Instead we have to use the paired difference approach. To use the large sample paired differences method, we need, of course, a large sample size, and by the central limit theorem we know the test statistic will be approximately normal. Our large sample confidence interval looks familiar. It's just the test statistic, the mean, the sample mean difference, bounded by a product of a critical value and a standard error. And what's different is just the standard error. It's the paired difference standard deviation divided by the square root of the sample size, number of pairs. The t-distribution we use to obtain the critical value is just going to be based on nd minus 1 degrees of freedom. This is our number of pairs minus 1. Our one-tailed test here is just a test if the difference in means is equal to some hypothesized value against the alternative that's smaller or larger. So we would generate a test statistic in a really familiar way, and then our rejection region is just corresponding to the area of possible test statistics that are more extreme than the critical value stipulated by the significance of the test. Our two-tailed test is similar. Now we're just allowing that the rejection region incorporates both tails. Right? So going between a one-tailed test and a two-tailed test isn't going to affect the test statistic, but it does affect the rejection region because now we're interested in two tails. Well, what do we do if we have a small sample? Then if we have a random sample of differences drawn from a normal population, we can use the small sample paired difference methods. It'll have a distribution that's approximately normal. Why? Well, because the population that we were drawing from was normal. What's the difference from before? Well, here we have a small sample. We'll use the t-distribution with nd minus 1 degrees of freedom. And then for the two-tailed test, all that changes is our rejection region. So one last comment on the paired differences approach. It may be better than an independent samples experiment. It also might not be. So one problem is we lose half the degrees of freedom when we use the paired differences because we're counting up our number of pairs. So we need it to be the case that the benefit for pairing is going to outweigh the loss of information in order to make up for sacrificing half our degrees of freedom to make it worth it. So ultimately we need to ask ourselves the question of whether pairing will or would not reduce the variability that we're going to be seeing. And then lastly, an important note, this determination needs to be done before you draw the samples. So it's a feature of the design of the experiment rather than something the researcher would decide after the fact.